fill out that flow chart. Alrighty, matter flow chart. So let's see here. Ollie, a substance with fixed ratios of elements, what is that going to be called?
Pure substance.
Love it, love it. Jeremy, a pure substance that only has one type of atom is called? Harry Case, elements are chemically joined but are still a pure substance. You got it! Love it. Hiddleberry, substances are mixed together but they're not chemically joined. That's called a... Love it. Norhole, if it's uniform composition or is spread evenly, has the same look. It's called a what?
I forget what exactly the two words are. If you chose them, I can tell you which one was which.
The choices are hetero or homo. Homogeneous mixture. Yep, a lot of people are throwing the homozygous at me from biology. Oh yeah. Oh yeah. All right, Tanner, and this means that a non-uniform composition where it's not mixed evenly would be... We had lots of examples of this yesterday. So an element example, here's some pure copper right here. Compound example, here's some NaCl, some salt. A mixture could be like tap water. Tap water is a good example of a mixture because it's got H2Os in there, but there are other things dissolved in. And here's a heterogeneous mixture of oil and water. The water is blue, the oil is sort of the yellowish on top. Now if I were to go like this, now it's a homogeneous mixture because they're mixed evenly, but not for very long because they will separate out again. If I plop that right there, about 3 or 4 minutes, it will be separate. All right, good times. So we're going to move into some new content here today. It's going to be really thrilling. We're going to talk about properties, starting with physical properties. So this is where you're ditching the packet for a little bit. You'll come back to it later, and you're going to want to get your notes out sometime. Some sort of scrap paper, notebook paper, 3-hole punch paper, whatever. And sort of get used to this where you'll use the packet, put it aside, take notes, go back to the packet, back and forth. We go. Teacher taught her. And Perry, were you able to watch the video from yesterday yet?
No.
Okay. All right. It's in the Monday folder, just so you know. And there is a 3-question quiz in there too, so you want to make sure you take care of that. Yep. Yeah, I think you really went absent yesterday. All right. I haven't gotten your way yet, have I, Ollie? Like if I like one of these where you can't see the board? You're gonna be the first one who knows if I'm in the way. Alrighty. So physical properties. There's a lot of different properties of matter, and there's one brand called physical. It can be measured without changing the chemical. It can be measured without changing the chemical. Okay? So for example, if I were to get out a ruler that's covered in salt. Alright. Glasgow! What is this? I'm holding in my hand. Do you remember? It's copper. I don't really care if you remember that. It's copper. Okay, check it out. Check this out. This is copper, right? Okay. It's about 6.5 centimeters. Hey, Haley, what is this now?
Copper.
Correct! Okay, did you see how I found that physical property without changing the substance? Okay, so a physical property, like length, for example, can be measured without changing the substance. It was copper, I measured it, it's still copper, therefore length is a physical property. Make sense? Okay? Chemical composition of a substance. Again, you don't have to write down every word I say. Generally speaking, you can observe it with your senses without really having to do a whole lot. So you can look at it, that kind of thing. You can smell it. Density is another example of a physical property. You can find the density of something without changing what that something is. Okay? So if you know the mass and the volume of a substance, you can tell me its density without changing what that substance is. Other examples of physical properties, you don't have to write all these down, but here are a handful of examples. You should know some examples. Well, you don't have to write all these down. So the color of something, the odor, the solubility, the size, the shape, the boiling and freezing point. Watch out for solubility. That's the ability to dissolve. That is a physical property. A lot of people think that's not physical, but it is. Okay? So solubility is the ability to dissolve. So if I want to test the solubility of this salt, I'll pour it into the water here, like so. And I can mix it in with a glass stirring rod. Wonderful. Kind of like one of these. Those of you at home, I've poured salt into this little container of water. I'm mixing it around. Good time. So solubility is something's ability to dissolve. A couple other little terms. If it's soluble, that means it can dissolve. If it's insoluble, that means it can't dissolve. So we say that salt is soluble in water because you can dissolve salt in water. If I keep mixing this up, the salt will quote unquote disappear, not really disappearing. It's just getting hidden in between water molecules, but the salt's not changing. It's just sort of sneaking in between water molecules. And saturation is when no more can be dissolved. So you get to a point where something's completely saturated, you can't dissolve any more of a substance in it. So imagine if I poured an entire truckload of salt onto this little beaker of water, okay? That'd be too much salt. That water would become saturated and it would get to a point where it can't hold any more salt. Can't hold any more salt. Okay. That's physical property, and please watch out. Some people will think, oh, the salt disappeared. It must have been a chemical property. Like, no. Solubility is a physical property because nothing's changing about the salt. It's just sort of hiding, but it hasn't changed. All right, chemical properties. Let's go, baby. Describes a substance's potential to undergo some chemical change. Describes a substance's potential to undergo some chemical change. Oh no, I hit it. Oh no. Whee! Anyways, some examples. Reactivity with water. pH. Flammability. So let's say I gave Amanda our little worksheet over here. I'm like, hey, sweet, let's see how flammable your worksheet is. Like, why would you do that? Why would you do that? Okay? Now, this little ashy part right here, is that still paper? Is this the same thing as paper? All this mess? It's not, right? Okay? So, it was paper. Now it's not paper. It's ash. Therefore, flammability is a chemical property. Because you can find out how flammable the paper is. You can find out how flammable your hair is, too. I wouldn't recommend it, though. One time I was in the middle of a conversation with this girl, and her hair caught on fire, and she had no idea. Crazy times! That's a true story. Her name was Kathy. Anyways, so flammability is a chemical property, because you can find out the flammability of paper, for example, like I just did. But at the end, you're not left with paper. You're left with ash. Same with reactivity in water. The pH is something. Okay? So the chemical properties, you can find it out, but you have to change what you're working with. You got to change what you're working with. All right. So we can take properties and we can call them chemical or physical. And we can also take properties and we can call them intensive or extensive. Okay? So we're taking properties and putting them in two different categories, physical, chemical, but you can put them in two different categories. It's sort of like the same thing as being like, okay, what high school do you go to? Oh, I go to the South. Oh, I go to North. But you could also be like, hey, what grade are you? Like, oh, I'm a sophomore. Oh, I'm a junior. So you're taking the same body, okay, the same properties, you just put them in different categories. Okay, intensive properties. They do not depend on the system size or the amount of material involved. Okay? They do not depend on the amount of the material involved. Some examples would be like, let's see here. Hey, Gabby, what color is this? What color is this now? What color is that? All right, hold on one second. Hold on. What color is that? Okay? Color is an intensive property. It doesn't matter how much of the stuff you have, the property remains the same. Hey, what's another intensive property that we've talked about a million times? Not mass. What's an intensive property? I mentioned this word last week a couple of times. Talking about something. Huh? Density, right? Right? Because water, okay. Remember this little example here? So I got water. All right. Hey, Maddie. What's the density of this water? What about this water, though? Hey, Maddie, what's the density of this water? Okay. See how it doesn't matter how much water you have, the density stays the same? That's an intensive property. Some people say it's intensive, it's about the internal, it's about the identity of the substance, not how much of it you have. The opposite of that, though, is an extensive property. Okay? Extensive properties do depend on the system size or the amount of material in the system. Bless you!
Thank you. It's allergies.
Allergies. So, for example, hey, Tori, let's pretend that this is 1 gram of paper, okay? Is this 1 gram of paper? Mm-mm. Let's say this is half a gram. Is this now half a gram? Mm-mm. Okay? So the less stuff you have, the less mass you have, okay? So extensive properties, they can extend or change depending on how much stuff you have. So again, there's a million examples of both of these, but you want to know a couple of them. So like, maybe for intensive, you know density, or color. What about one of the ones we already talked about? You don't have to write all these down. Flammability. Whether something's flammable or not does not depend. Are there 2 M's in flammability? I think there are. Whether something's flammable or not does not depend on how big it is. But extensive properties, so you have stuff like mass. Or you could say length. The length of that paper is changing every time I tore it in half. Okay? There's all kinds of things. All right, so you can take properties, you can put them into physical or chemical, or you can take properties and put them in intensive or extensive. Okay, so you got a few options. All right, now we got to talk about changes. So if you want to change something, okay, there are physical changes, which is the first brand. Occurs when substances do not change their chemical identity. Okay. No new products are formed. Let me see here. Hey, Kelsey Schmidt, I know you're there somewhere because I saw you earlier. Can you hear me?
Yeah.
Oh, hello. All right, hey, Kelsey. I have a question for you. There we go. Hey, Kelsey, what is this? What material is this?
For you, your camera looking at you is frozen for me.
My camera's frozen? Weird. Huh.
At least for me, I don't know about everyone else.
Hey, someone else
Oh,
speak
you're not
up.
frozen, now I can see.
Oh, I can? All right. Hey, Kelsey, what is this in my hand?
Paper.
What is this now?
Paper.
Hey, Kelsey, pop quiz, what is this?
Paper.
Oh, man, wasn't that fun? All right, the idea is I'm tearing it in half every time, but it's still paper. Still paper. So that's a physical change. Physical change, physical change, physical change. Because it's still paper. Still paper. I didn't change what it was. These can usually be reversed. I put stars usually. Okay? Because you're like, wait, how do you reverse this? Like, can you duct tape that back together? Like, the idea is that it's not really changing anything, and usually physical changes can be reversed. Now, there are some tricky physical changes that you need to be aware of. Okay? State changes. Changing states is a physical change. Can't emphasize that enough. I will absolutely be quizzing you over that. You better believe it. Changing states is a physical change. So is dissolving. Dissolving is a physical change. So, for example, when I take salt and I put it in the water, so here's a salt crystal. Here's like a big lump of salt. Here's the water molecules. When I drop it in there, you'll have little water molecules flying around. The salt crystals will be in smaller pieces, but they're still just salt crystals. Okay? So dissolving is just a physical change because it's still just salt, it's still just water. They're just sort of mixed in with each other. Okay, H2O, boiling. Okay? Let's see here. Hillberry. Do you know what the chemical formula for water is? Do you know what the chemical formula for steam is? You got it. Okay? It's H2O either way. If I were to freeze this, what's the chemical formula for ice? H2O, okay? The point is, whether water's frozen, it's steam, it's liquid, it's H2O. So changing states, going from solid to gas to a liquid or whatever, is a physical change because you're not changing the stuff that you got. Okay? Still got the same stuff that you got. All right. Now that does bring us to chemical changes. Chemical changes. There'll be a little bit more to write down with this one. That occurs when a substance changes into or becomes a different substance. So what you had before is not what you got now. What you had before is not what you got now. Chemical changes happen at the molecular level, so the atoms and molecules are changing themselves. So like at the tiniest level. Chemical changes are usually irreversible. Evidence of chemical change. Now this is a big deal. You need to be able to recognize when something is a chemical change, so you need to know the signs, okay? Sort of like when we talked about chemical burns, you need to know the signs of a chemical burn. You need to know the signs of a chemical change. You have to be able to recognize it. Okay. A gas is produced. A gas is produced. And no, I'm not talking about boiling, okay? I'm not talking about water just turning to steam. I'm talking about a gas. Por ejemplo, Come on. Oh, it's hard to blow that out. Oh. See this? Gas being produced? Yes. Okay. I just lit this paper on fire, a little bit of smoke came out. That's a sign of a chemical change. Please don't go towards that sprinkler. Okay. All right, anyways. All right, another example. The temperature changes by itself. So this is where you mix a couple of things together and it gets pretty cold. Or you mix a couple of things together and it gets pretty hot. That's a sign of a temperature change. A temperature change. Or even this paper got a lot hotter. So I lit it on fire and then I took the flame away and it continued to get hotter on its own. Okay? Sort of like a campfire continues to get hotter on its own once you light it. As an example of a temperature change. A substance disappears. And again, I'm not talking about dissolving where the salt, quote unquote, disappears in the water. So let's say you pour two liquids together and the white liquid all of a sudden just, it's like, what? Where'd it go? It's gone. What happened? Is new substance is in its place. A color change occurs. Okay, a color change is definitely a dead giveaway. You had a chemical change 99% of the time. So again, this is orange paper right now. Dang it. This is now got a kind of gray, dark gray, black color to it. That makes me think there's a color change. That makes me think it's a color change. That makes me think there's a chemical change because there was a color change. Another sign of a chemical change, an odor is produced. Take a whiff of that.
No, I already smelled it.
Yeah, do ya?
Yeah, I already smelled it all the way from over
Oh, I should waft it through.
You actually like to smell the smoke?
No, not really. But it definitely has a real fine odor. I think it's probably reached all of your noses. And someone in the virtual room is like, I got it too, Mr. P. They're like, oh, that's... Are you hiding in the cabinets? Okay. Anyways. So, an odor being produced, or a new solid is formed. Again, this is not freezing. If you pour a couple things together and all of a sudden a solid is produced, which we have some examples that I can show you guys at another time, that would probably mean you have a chemical change. So, an example of that, I'll show you tomorrow. Ask me again, I'll show you tomorrow. How about that? So if you're trying to figure out whether something's a physical or chemical change and it checks a couple of these boxes, like, well, it did give off a gas, it really stunk up the room, and it had a color change, okay, it probably is a chemical change. So these are like pieces of evidence you put together, like, okay, well, I think it was probably a chemical change based on this, this, and this, if you had to argue to me on a test or something like that. Yep. Alrighty. So let's go ahead, let's go back to that original worksheet. Let's see here. So you guys will be working on this part 2 of this worksheet right here. So this is the one we start on with the flow charts. So that's what we'll be getting to. The first thing I suggest you guys do, so virtual folks, why don't you go ahead and take that 3-question lecture quiz on Schoology. In-person folks, why don't you go ahead and get out your device and take that 3-question quiz on Schoology. And then when you are done, go ahead and work on this worksheet that's in your packet. It's page 3 of the packet, so we skipped a page. And that'll be that. Virtual folks, you can go ahead and get on out of here.